All right, so what, yeah, you're referring to a question that is using this illustration right here. Okay? And let's see. The question is right here, number 17. All right, so the image shows the volume of a liquid remaining in a burette. The original volume was 1.12 milliliters. Okay, so this is the amount of liquid that's in there after some more has been taken out. Notice the direction of the numbers. This glass container is numbered so it gets smaller going up. So somewhere up there is a 0. Right? Alright, so if we originally had 1.12 and now it's down to this point, we have to subtract to find out how much was taken out. Okay? So first thing we need to do before we do anything else is figure out how much volume there is listed on here now. Remember, we always read the bottom of the meniscus. Okay, Carolyn, what were you saying?
9.6.
Okay, that would be great if you were in physical science. But here in this chemistry class, we're going to estimate where we are in between the smallest markings on the device. So the smallest marking there is 9.6 and 9.7, but if you look at the meniscus, it just dips just slightly below that. Okay, what did you say, Dev? I think 9.65 is too far.
2 or 1.
Yeah, 2 or 1. That's just barely below, right? It's really close to 9.6, so you got to be, I'd say 9.6 is a good place to do it. 9.6 is a good, but we want to have that 9.62 maybe. Can we go with 9.62? 5 is right here. See, here's 4, there's 5, there's 6. Okay. If you look, when I copy these, I look really carefully to make sure you can actually make them out. And if you look carefully at your image on your practice test, you can make out where those lines go. Okay? So there's 4, 5, 6, and it's slightly more than 6. So 9.62 is reasonable. However, I would accept 9.61 or 9.63. Okay? Because that last digit is an estimate, but it's got to be a reasonable estimate, and that's why I would not accept 9.65. That makes sense, Deb? Okay? All right. Now, just a number is not enough. You got to tell me what the number applies to. Very few things in chemistry can you just give a number. All right. Most of the time, you got to tell me what it applies to. So the question says these are in milliliters. So this is 9.62 milliliters, and you should also tell me what the species is. Now there's not a lot of information about the species, so you could list it as simply liquid, or you could call it an unknown if you wanted to. I'm going to put down UNK for unknown. How about that? All right? All right, so our original amount was 1.12 of this unknown liquid. And so to find out how much was taken out, how much was dispensed, I need to subtract.
Milliliters of that unknown.
Exactly. Now, if there were any missing slots over here, we'd have to round off. But there are no missing slots on the right, so we don't have to round off these digits. Okay? That is the final answer. Everybody got that? Okay? What is the next question? Nobody has any questions?
Oh,
yeah. Okay, Maurice?
86.
Okay.
What is the correct formula for a combination of aluminum and sulfite?
Aluminum and
Sulfite.
sulfur?
No.
Sulfite.
Sulfite. Aluminum and sulfite. And we're looking for a formula, correct?
Yes.
All right, so the symbol for aluminum is capital A, small l. Okay? And what's this? Now, sulfite, that ITE ending. What does that ITE ending tell you?
That it is.
It's a polyatomic ion, yeah. Okay, so you're right. There are 3 oxygens and all that. But the big thing is 8 endings tell you it's a polyatomic ion. 8 endings tell you it's a polyatomic ion. Okay? There are a few others that have some other endings, like ammonium. You just have to know that's a polyatomic ion. Okay? So where are you going to find the formula for a sulfite then? Common ions list is where you find it, and it's SO3, 2 negative. All right, I need another charge on the aluminum. Where do I find that? What? What did you say? You have the periodic table with oxidation numbers. Okay. There's aluminum, and it has a 3+ charge. So all we need to do is to find a combination that will cancel out all the charges. We can use as many aluminums or sulfites as we need to make it work out. All right. So let's see, we got a 3+ charge here on this aluminum. We got a 2 negative charge here on this sulfite. And the math I've taught you is you got to look for coefficients that when you put it together in this equation gives you a 0 charge overall. Okay? So I need a 3 here and a 2 here, wouldn't you say that? Okay? So that means that in this, when I'm putting together these 2 ions, we need 2 aluminum ions plus 3 sulfide ions. Okay? The coefficients then become subscripts when we put together the formula. Because once you bond, the coefficients means it's a separate, there's 2 separate things and 3 separate things. When we bond them together, that's when you use subscripts. Subscripts tell you they are bonded together. So aluminum with a subscript 2 and sulfite with a subscript 3 tells you all of these are bonded together. Okay? We learned this in Unit 3, and then in the last unit when we're doing equations, we learned to take it back apart to build those complete and net ionic equations. You said you want me to do number 86? 87. Yeah, we did that yesterday. Sure did. And I believe that one is on the website.
It was number 26, I think.
26?
Is that like the same thing?
Are they the same question?
I don't know, but I know it's like the same thing.
Yeah, they are the same question, aren't they? How about that? The hybridization is SP3, but to understand how you figure that out, if you go to that video that's on the website, okay, look at, and I forget what the number is, but it's all that. I didn't actually record this class as I was having problems with the recording, but in my honors class I did exactly the same thing, the same explanation, so it's on there someplace, okay?
What about
Okay, in what product would the product, in what state of matter would the product containing carbon be? Okay, so this is a combustion reaction here we're talking about. So number 98 is referring to number 97, okay? And so this is what class of compound is this? Huh?
Yeah.
Well, I'm not looking to name it. I'm just saying what class of compound is it?
Yeah.
Hydrocarbon. All right? Hydrogen is a carbon. It's a hydrocarbon. So if I have a hydrocarbon and I'm reacting with oxygen, I'm using flame to initiate the reaction, what classification of equation is this? Okay? And what does combustion produce besides these 2 chemical products? Heat and light. Okay? Well, you don't need heat to figure out the physical state of this, because at room temperature even, this is the same physical state anyway. What physical state? This is what it's asking for. What state of matter with the product that contains carbon? Well, that's that right there. The product's on the right side. This is the product that contains carbon. What physical state is it going to have? Gas. Both products in a combustion reaction are gases, and the water is a gas because of the heat.